Hello everyone, this is our session 18 on indefinite integration. We were on exercise 3.3, question 1. Okay, so we finished around 17 sums of that. I'm doing the 20th one now. So two more sums of this question and then we go to the next type. Okay, so this is exercise 3.3, question 1. 20th sum. So I is equal to integration of x sine 2x cos 5x dx. Okay. So now if we are using integration by parts, okay. So what can we write? Integral uv dx is equal to u integral v dx, right? Minus integration of d by dx of u integral v dx dx. Okay. Now, which is our first function here? X, and which is our second function here? Sine 2x cos 5x. Okay. So, when you substitute the formula here, the theorem here, we get I as x integral sine 2x cos 5x dx minus integration of d by dx of x integral sine 2x cos 5x dx. Okay. Now, so what you can observe here is we have an integration whose value we don't know, that is this over here. So what we'll do is we'll find out its integration separately. Okay. So let us take integration of sine 2x cos 5x. Now sine 2x cos 5x dx can be written as multiplying dividing by 2, the 2 sine 2x cos 5x. Okay. Now this can be written as, this is a formula for sine a cos b, right? 2 sine a cos b. So how will we write that? Which is equal to half integration of 2 sine a cos b is sine a plus b, that is 2x plus 5x, right? Plus sine a minus b, sine 2x minus 5x. Okay. So which will be equal to half of integration sine 2x plus 5x is sine of 7x, okay, minus sine 3x dx. Let's separate the integration. So we have half integral sine 7x dx minus half integral sine 3x dx. Okay. Now, what is the integration of sine? It is cos, so half, rather minus cos 7x upon 7. Okay. Minus half as it is, minus cos 3x upon 3, right? Plus c1 we can write. Now, we can take that minus sign out and we'll have minus, final answer is minus 1 upon 14 cos 7x, okay, plus 1 upon 6 cos 3x, okay. And this is your integral value. Now, you want to write plus c1, you can write, you can leave it as it is also. So sine 2x, sine 2x cos 5x dx value I have. Now we'll put this value in our integration I. What was I equal to? X integral sine 2x cos 5x dx, right? So we write I as x. What is integral sine 2x cos 5x? It is minus 1 upon 14 cos 7x plus 1 upon 6 cos 3x. Okay. Let's go back to the value of I. So minus integration of d by dx of x is 1. Okay. So we have minus integration of d by dx is 1 and the value of integral sine 2x cos 5x minus 1 upon 14 cos 7x plus 1 upon 6 cos 3x. Okay. Now let us integrate this last part over here, right? So we'll have this equal to minus x upon 14 cos 7x plus x upon 6 cos 3x, okay, minus into minus plus 1 upon 14 as it is, cos 7x integration is sin 7x, so 1 upon 14 sin 7x upon 7, okay, and minus sign multiplied inside, minus 1 upon 6 sin 3x upon 3, okay, plus c. Now the last part is to multiply the denominators that are remaining. So let me write the final answer for you to be equal to minus x upon 14 cos 7x first term plus x upon 6 cos 3x plus 1 upon, what is 14 into 7, 98 sin 7x minus 1 upon 18 sin 3x plus c. Okay, so that is your 20th question. Now the answer of this question in your textbook is misprinted, so be careful while solving the sum. Okay, let's move to the next one. I'm doing the 21st one now. Okay, so 21, I is equal to integration of cos of cube root of x dx. Okay, so we can see that there is a function within a function, so let us use substitutions. We say let cube root of x equal to t. Okay, that means x is equal to t cube, okay, and dx is equal to 3t square dt. Okay, so I will be equal to integration of cos of t into dx is 3t square dt, which we'll have to rearrange and write it as 3t square cos t for our Light rule. What is the Light rule? Logarithmic inverse, algebraic, and then trigonometric. So I'll put the algebraic function first, 3t square, and then the trigonometric function. We'll use integral uv dx. What is the formula? Integral uv dx is equal to u integral v dx, right, minus integration of d by dx of u integral v dx. Okay, now let us use the formula for I. So I will be equal to u integral v dx, first term as it is 3t square, integration of cos t dt, okay, minus integration d by dx of 3t square, sorry, d by dt of 3t square, integration of cos t dt, and this whole thing multiplied by dt again. So I will be equal to 3t square sin t, okay, minus integration of 3t square is 6t, okay, multiplied by integration of cos t dt will be sin t into dt. Okay, now what do you have to do for 6t sin t? Again, we are going to use the uv rule, that is integral uv dx. Okay, so 3t square sin t remains as it is, okay, minus 6 outside, integration of t sin t dt, and we are going to use uv rule for the second integration. So let us do this. I is equal to 3t square, using the uv rule for the second function, minus 6t sin t dt. So t sin t, so t integral sin t dt, t by dt of t sine t dt. Okay, so we'll have 3t square sine t as it is. Okay, I'll put the 6 inside, so minus 6t. Integration of sine is minus cos t. Okay, minus into minus plus 6, and d by dt of t is 1. Integral of sine t is minus cos t. Okay, dt. 3t square sine t plus 6t cos t minus 6, and integration of cos t is sine t dt. Okay, so we can have 3 sine t, not dt, plus c, this will be here. 3 sine t common, so we have t square minus 2 plus 6t cos t. Okay, plus c. What we'll do is now substitute the value of t. So this will be 3 sine third root of x. Okay, now t square, so you can say third root of x square minus 2 plus 6. T is cube root of x again, cos of cube root of x plus c. Okay, this term here can be written as x raised to 2 by 3. So that is your final answer for question number 21. Okay, now moving to second part of this exercise. So exercise 3.3, question 2. Okay, again it says evaluate, but the type of sums are based on the formulas we have done for integration by parts. That is integral of root of x square plus a square, integral of root of x square minus a square, and root of integral of root of a square minus x square. Okay, so let us do this. The first and second sum are similar to question 10 of the first question. Yes, I'm not doing those. Moving on to the third sum. So the third sum is sine of log x. So I is equal to integral sine of log x. Okay, dx. So since there are two functions within one, what we do is we put log x as t. So we say let log x equal to t. Right. So x is equal to e raised to t, and dx will be equal to again e raised to t only. Right. So let us put I as integral of sine t into e raised to t dt, and this type of integral we have done before. Right. So either you can use the formula or you can use integration by parts and solve the sum. Okay, sine t e raised to t. Now also remember the Light rule over here. So Light rule says that exponential should be in the end. So yes, it's in the end and trigonometric first. You can directly do the integration of this function. Okay. Also, if you integrate it in this form, e raised to t sine t dt, then you get a easier answer or easier integration, I would say. So I'll use the the uv dx rule over here. First term as it is integral sine t dt, right, minus integration d by dt of e raised to t integral sine t dt. Okay, so which is e raised to t minus cos t, okay, minus integration e raised to t into sine integral sine t dt will be minus cos t, and this whole thing dt, okay, which is equal to minus e raised to t cos t, okay, minus of minus becomes plus integral e raised to t cos t dt. Again, use integration by parts for this function. First function as it is. For the second function, we'll write plus bracket. Now, integral e raised to t cos t dt, first function as it is, integration of cos t is sine t. Okay, minus integral d by dt of e raised to t. Integral of cos t is sin t dt. Okay. Now, this can be written as I is equal to, or rather, I'll write the value of I so you know how we are solving this. Integral e raised to t sin t dt is equal to minus e raised to t cos t, okay, plus e raised to t sin t minus integration of d by dt of e raised to t is e raised to t sin t dt. Now, what can we observe over here? E raised to t sin t dt, e raised to t sin t dt. That means I value is repeated. So, I'll call this as I. So, this will also be I. Shifting this on the other side, we get 2I is equal to e raised to t sin t minus e raised to t cos t. So, we'll have e raised to t common, sin t minus cos t. And we take the 2 down. So, I is equal to e raised to t upon 2 sin t minus cos t plus c. Okay. And then you can substitute the value of t. So, what is the value of t? Log of x. So, e raised to log of x upon 2 sin log of x minus cos log of x. Okay, plus c. Now, what is e raised to log of x? It is e raised to log to the base ex. So, the value is x. Okay, so do not forget to simplify that part. So, this will be x. So, that should be your final answer. Otherwise, you lose half a mark for that one step. It's simple enough. Okay, let's move to the fourth one now. Fourth one, I is equal to integration of root of 5x square plus 3. Okay, now this is pretty simple. Otherwise, like I'll just show you the methods. You can use it for the other sum, which is root 5 we'll take common. So root 5 integration of root of x squared plus 3 upon 5. Okay, now this is of the form root of 5 integration root of x square plus root of 3 upon root of 5 the whole square, x square plus a square. Okay, so I'm going to put the formula for you over here for integral of root of x square plus a square dx. We have done this in previous sessions, as well as it's a formula when we did integration by parts introduction. I'm giving the formula over here. It is x upon 2 root of x square plus a square, okay, plus a square by 2 log of x plus root of x square plus a square. Now, the method of getting this answer, we have done it previously. I'm just telling you how you get this answer. Like, you don't have to solve it. You can directly write the answer if the sum is for 2 marks. Okay. Now, if it's more than that, if it's for 4 marks, then I would advise you to derive this formula. Now, how do you derive it? So, you take the first function as u and your second function as 1. Okay. Sorry. Yes, the first function as u and second function as 1, and then you will use integration by parts and get the answer. Okay, so this is how you are going to solve this. Now I'm going to directly use the formula for this sum over here. So we get I equal to root of 5 is already present. Let us put the formula for integral root of x square plus a square dx, which is x upon 2 root of x square plus a square. So x upon 2 root of x square plus 3 upon 5, okay, plus a square upon 2. So plus 3 upon 5 upon 2 log of x plus log of x plus root of x square plus 3 upon 5 plus c. This is your final answer. Okay, the square bracket. Now simplifying this, we can take half common, so we have root 5 upon 2 bracket x root of x square plus 3 upon 5, okay, plus 3 upon 5 log of x plus root of x square plus 3 upon 5, okay, plus c. This is your final answer. C can go outside the bracket, the constant term. So we plus c. Okay. Now that's your final answer for question number 4, exercise 3.3, the second part. Okay. Now I'm doing the next one, that is fifth one. Okay. The fifth question, I is equal to integration of x square root of a square minus 6 a square minus x raised to 6 dx. Okay. Now, here we know that it's not of the form a square minus x square. So what we'll do is we will substitute the, or we rather try to get it in that form. So what we can do is we write this as x square root of a square minus x square or x raised to 3 raised to 2 dx. Okay, now this type of, there's a substitution here that we can use. What is that substitution? Let x cube is equal to t. Okay, so we have 3x square dx is equal to dt. Okay, and therefore x square dx that is there in our integral can be written as dt upon 3. Okay, so I will be changing to integration of x square dx will be 1 upon 3 dt. Okay, and root of a square as it is minus x cube is t, so a square minus t square. Now this is the simplified form where I can use the formula. So I'm going to write down the formula for you so that it's a quick reference. What is the formula that we are using? Integral root of a square minus x square dx is equal to x upon 2 root of a square minus x square, okay, plus a square upon 2 sine inverse x upon a, okay, plus c. This is the formula that I'll be using. This we have derived in the previous sessions. You can check for the derivation over there. You take the second function as 1 and then use integration by parts to get this formula. What you can do is solve it for the formula and use it for the sum. Okay, or you solve it for the sum directly. Two ways of doing that. Let me use the formula directly over here for you. So I will be equal to I is equal to, what's the term outside? 1 upon 3, we'll keep it outside, bracket, integral root of a square minus t square dt will be equal to x upon 2, that is t upon 2, root of a square minus t square, okay, plus a square upon 2. We have a only, right? Yes, we have a only. So a square upon 2 sine inverse x is t, so t upon a plus c. Okay, let us take 2 outside. So we have 1 upon 6. Let's substitute what is t. T is x cube. So x cube root of a square minus x raised to 6 plus a square upon 2 sine inverse x cube upon 3 upon a plus c. Okay, that is your final answer. Now again, this sum has a different or printing error in the textbook. The answer to the sum is different. So while solving, be careful. This is what you're supposed to get as the answer. This is question 5. Let's move to the next one. Sixth one now. Okay, so it is root of x minus 3, 7 minus x I is equal to root of x minus 3, 7 minus x, okay, dx. How do we solve this type now? So we are going to multiply the brackets here. When you multiply, then you get minus x square plus 10x minus 21 dx. Okay, now how would you solve this? So again, if you remember, how do we solve quadratics? We use completing the squares method. So when we use completing the squares, this can be written as under root of, we'll take minus sign common. We have x square minus 10x plus 21 dx. Okay, how do you do completing the squares? So minus 10x is the coefficient of x. Half of that is minus 5, square of it is 25. So we have to add and subtract 25. Okay, so we'll get under root of 4 minus bracket x square minus 10x plus 25. When you do add and subtract of 25 to this is what you should get. Okay. Now this will be written as under root of 2 square, okay, minus, this is x minus 5 the whole square dx. So this is basically a square minus x square. Okay, and now we'll use the formula for a square minus x square. So integral root of a square minus x square. Okay, again I will write the formula for you. Integral root of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse x upon a, right, plus c. Let us use this for our sum. So I will be equal to, do we have anything outside? No, it's just this root of 2 square. So this will be x minus 5 upon 2 root of a square, that is 4 minus x minus 5 the whole square plus a square upon 2, that is 4 upon 2 sine inverse x upon a. So x minus 5 upon a is 2 plus c. Okay, now we can take half common. You can have inside x minus 5 root of 4 minus x minus 5 plus 4 sine inverse x minus 5 upon 2 plus c outside. Okay, so that is your final answer for sum number 6. Okay, now this over here is your sum, is your quadratic, so you can change it to your quadratic as well, or leave it as this also, it's fine. Basically we look for simplified answers, and that's why you might lose half a mark for that. It's better you simplify it to the quadratic and then write the final answer. Okay, now we've completed around 6 questions of that. There are 2 more types that we need to address to, and then we move to the last part of the chapter, that is integration by partial fraction. Okay, so we take 2 more sessions for indefinite integration, and then we finish with this chapter. While doing these sums, if you have any doubts, you can write to me. I will solve them and send them to you. Thank you so much.